It's time for a vintage test gear repair video. This is a Philco alignment generator, model 7008. And I covered this about 12 years ago when I got it. Well, the time has come. I need something that will do sweep alignments on the older IF frequencies, the 25 megahertz area on the older TV sets. And this is only got one marker, but this is sort of an all-in-one package. It's got the scope up here. It's got a marker generator here, and it's got the sweep here. So this is sort of an all-in-one solution. I just wish it had an input for an external sweep signal. That way I could use the little micro signal generator to generate a marker. And that way I would, would know that it's dead on frequency. So this says for television and FM, but down here it says AM/RF. So I'm not sure. I'm going to try and find a manual. This thing needs to be totally recapped. I know that, so we'll do that. But I want to bring this back to life. I do have plans on doing a lot of older televisions in the future. And I kind of want this to work, because sometimes it's really handy just to be able to take a look at the sweep band pass. And I think this will do it. This goes all the way up to 260 megahertz. And basically the marker goes up to 250. This thing will almost do tuners, I think. I'm going to see if I can find a manual on it. That would be very helpful. But I'm going to get it apart and start the recapping process, and we'll take a look at the inside. What generates the sweep is pretty cool. It's mechanical. All right, so let's take a quick look at the inside of this. All of these are leaky. I cut that one out of circuit. There's a bunch of paper capacitors down here. This thing's built really well. This is what generates the sweep. And see how that looks like a speaker spider? Well, that's how that thing works. That is a vibrating capacitor. That basically moves up and down just like that. And that inside there is a capacitor. So that's how it generates the sweep. It's mechanical. This really is very nicely built. But I do need to recap it. I checked the ESR on the filter capacitor down there, and it is high. It needs a new filter. Some of the resistors don't check real good, but we'll have to just see how it works and then go from there. There's the calibration crystal. Beautiful test equipment. This is one of the adjustments. Look at this thing. Let me look at that. That's the frequency. Just such good quality. And the transformers are branded Philco. The tubes are branded Philco. This is made by Philco. There's the little CRT in that box, nicely shielded. I just hate to recap something like this because it's such a work of art, but it's unusable with these leaky paper capacitors in it. I wonder if that's paper right there, that domino, or if that's mica. Very nicely built. I pulled a few of these wax caps loose, and they're very leaky and off. They've gone up in value. I almost hate to recap it. It's such a thing of beauty. You can see how much time they took to make sure the outside foil was all in the right spot on the low impedance side. I did pick up a bunch of caps. Just hate to put this modern Chinese junk in place of these, but it's never going to work unless I do it. They are all leaky. So there's all of these here, and then there's a bunch down in here. The electrolytics are kind of dried out. So if this thing is ever going to work any reliably, it's going to have to be recapped. There it is. I tried to do as clean and nice of a job as I possibly could. I don't like it. Makes me feel dirty to violate it with these aftermarket Chinese parts. I got to do these down here. They're going to be a little bit tougher to get to. But like I said, they all got to be changed. They were not easy, but I got the rest of these capacitors all changed. So now all of the paper capacitors are out of this thing. Doing our first power up here after the recap. Changed all those wax capacitors. I'm on the dim bulb. I don't have anything yet. Let's see, intensity, max. Okay, I'm going to bypass the... It's been on the dim bulb for like 10 minutes. Okay, that's full line voltage. Let's see, intensity's all the way up. Focus all the way up. It's not good, is it? Phasing, I don't really think that would matter just to get a dot. Blanking, I don't know. This is vertical gain, horizontal gain. I would think we should be able to get a dot or something. I remember getting something previously. Hate these Loctile tubes. Just nothing. Hope the CRT didn't go bad. This is the CRT right here, and this is a little bit unhappy. This is not even slightly warm. And there is no hint of glowage here. This is not good. Actually, I'd take that back. In the dark, you can see it here, and you can see a little bit of a green dot right there. Let me see if I can move that. Oh, really? Yeah, there's focus. Okay. There's intensity. Wow, is that dim? Maybe it's due to the bad filter capacitors, or maybe it's a weak tube. Now this is weird because I can get it to go. I can get the dot to go around the perimeter, but I can't get it to come. You can see it there, but I can't get it to come onto the front here. I get it over here or over here, but I can't get it to actually come across where we can see it. Well, I'm just sort of testing the functions now, even though the display's not working right. And I'm looking at the marker generator, and I got it on the signal spectrum analyzer here, sit right about 25 megahertz, and that's actually dead on 25. So that's good. Let me try the sweep. And the electrolytic just puked its guts out. The marker part appears to be working and is right on. The master oscillator, no. I switch from A to B, and it doesn't make any difference. That's off. That's A. That's B. And as you can see, one should be low band and one should be high band. Okay, I got it working on the low band. I read the theory of operation. We'll go over that, but I'm going to adjust it real quick. Basically, it has two oscillators. It has the variable oscillator right here that's modulated with sweep, and then over here it has a fixed oscillator at 140 megahertz. So I'm going to adjust this one to 140 megahertz. So I'm going to pull this one out. So basically what it does is it gives you the sum of the frequencies, the core frequencies, and the difference of the frequencies. It gives you 4 components when it's in low frequency mode. It's actually pretty close at 139. And this right here will adjust that. So let's see. That's good enough. Now this one's way off. I'm on B band. So I'm going to set this one up at about 150 and then try and adjust this one to 150. And it's 7 megahertz off. It's not that big. There's an adjustment screw right in the middle of this variable inductor. Right here. Okay. Using the scope, I've confirmed all of this is pretty much aligned and working. Now I just need to figure out why this won't work. What's going on here? I feel like I'm real close. The filter capacitor did get really warm. I did not reform it gently like I should have. I should replace it. There's also another capacitor up here. I think this one is starting to blow out too. I might replace that one. And actually, I think we're there. There it is. We are there. It's working. I mean, I know it's working by looking at it with the scope. I don't need to hook it up to something. So what we're going to do, we should be able to feed a signal into this and look at it, although it's not a linear deflection. It explains that in the manual. It's different. It's not like a regular scope. You can't just use it as a scope. You can sort of use it, but not use it fully. Like, check this out. If I touch the input with my finger, this is a 15 microfarad, 475 volt capacitor, filter capacitor for the B minus. And I'm pretty sure the reason why we weren't getting anything on the CRT in the beginning is because this thing was leaking, because you can see how that it squirted that little nugget out right there. I don't believe that was there earlier. So anyway, what I've done is I've cut it out of circuit and I've replaced it with a 22 at 450. That's all I got. So I think the modern capacitor should be able to handle it okay. It's probably about 410 volts. Well, I do have one other problem here, and I've tried spraying it, but this pot is bad. It's like, that's on 9, that's on 10, it's going down towards 9, and then that's it. So this is a double pot too, and it's bad. Yeah, there it is. And I see how they have them wired. They have them sort of wired in series parallel. I wonder why they're doing that. That's very interesting. I hate to get rid of that, but I don't see. It's obviously one of the two of them has a broken, a crack in the carbon track. And that electrolytic is still getting hot. I need to change that, but Access is so limited. The 4-section electrolytic has been replaced. So we've got 1, 2, and you can see I cut the wires here going to it. 3. This is the only one I had to cut the lug off to get it out of circuit, but it is right here. And then 4 is over here. And again, they're all, this main electrolytic that's leaking everywhere is completely out of the circuit. So we're completely recapped now. All wax, all electrolytics. The only thing that I didn't touch are the micas, and I believe they're fine. This is the only other thing I got to deal with, which is this flaky pot. And I don't know why they did this. They've got 2 pots stacked on top of each other. The bottom one is the one that's bad. The signal comes in right here. It goes to ground there. And then from this one, it cuts down to the bottom one. So you can see here what they've done. The signal comes in here. I don't understand why they did this. This would screw with the linearity, wouldn't it? It would change the linearity. I'm not sure why they did this. Anyway, what I'm going to do is I'm just going to delete the bottom one. I really don't have a choice. And I'm just going to jump this straight to here. I'm just going to bypass this one. Also, we should take a look at this FM modulator tuner assembly. So this right here, this variable inductor, is that. That is a variable inductor. And then this right here is the speaker voice coil, and you can see these 2 capacitors right here. And as this thing vibrates up and down, those capacitors vibrate. The capacitance vibrates. That's how it generates the sweep. You can see exactly what's going on here. It's a spider, just like a speaker. And there's a magnet and a voice coil. And just, these are the 2 capacitors right here. That and that. And that's the variable capacitor. As that vibrates, it creates the modulation for the sweep. It's totally mechanical. And those 2 capacitors are just, you know, across this inductor, this variable inductor. Okay, I deleted the bottom section of this pot. I moved the piece of coax you see there on the left to the top section. So let's see how the output looks now. Now, continuing on with this thing, this oscillator is driving me crazy. That is this oscillator right here. And if I turn off, if I put it on B, you can see it's not stable. That's exactly, you look at it on the scope, that's what it's doing. So you put this on A, which turns on the additional 140 megahertz oscillator, which is this one right here. That one, you see how stable it is. Well, now it's stable. No, there it just started flaking out again. So this one is stable. The 140 divider is stable, but this is not stable. If I adjust the frequency, I'm going to try changing that tube. It's just no good. It's just garbage. I don't know, you look at it here, it looks more stable, but over here it just... I don't get it. Maybe I need to just test it on a piece of equipment. Well, if I listen to this, it sounds like it's working. If I turn that and I widen this up, I think it's working. We just need to try and align something with it. I may end up changing this connector to a BNC, and I just happened to find the right BNC today that'll actually fill up that hole. So it is a thought to change that to a BNC. I think we're working here. I know it hasn't been much of a video as far as, repair, diagnosis, and repair, seeing happy sunshine, lollipop, smiley face results at the end. But you're going to see this in future videos where we actually use it to do some alignments. I might try and connect it to an FM radio just so we can look and see if we get the S curve. Okay, I got it hooked up to this Westinghouse AM FM radio here, and I'm just going into the antenna with 10.7 sweep, and I'm looking at the S curve out of the volume control. And there you go. So there it is. It is working. And it is working good. I don't know what to adjust on here to change this. It's a little bit on the bottom. You bring it up a little bit, but there it is. It is working. So we are ready to align some TVs. And there you can see even more that it's shifted down. So aligning the final IF, FMIF, you'd be able to tweak this up and center it.